This presentation provides an overview of the Aparian HDLC router. The HDLC router provides an interface between Ethernet IP and HDLC protocols. In this presentation, we will cover an introduction of the product, various application and migration examples, how to configure the product, and some of the diagnostics provided. The HDLC router is ideal for interfacing Rockwell Automation Logix platforms to legacy GEM80 devices and controllers via the GE StarNet communication card. The module uses a small footprint DIN rail mount enclosure with a wide input voltage range of 10 to 28 volts DC. It provides a standard 10 to 100 megabit per second full half-duplex auto MDIX Ethernet interface. The module supports the following HDLC protocol and physical implementations on the RS485 interface. It can operate as an HDLC master or slave, operate at 48K or 180K baud, supports NRZI, FM0, and FM1 encoding, and supports 2-wire or 4-wire RS485. The HDLC router supports up to 10 HDLC nodes with a total of 192 16-bit words being exchanged in each direction between the Logix controller and GEM80 PLC. Application examples. The first application example allows the Rockwell Automation ControlLogix controller to exchange data with the legacy GEM80 PLC. The HDLC router connects to the Logix controller over Ethernet IP and exchanges data with the GEM80 PLC over HDLC via the GE StarNet communications card. In this example, the HDLC router can be used as a master or a slave on the HDLC network and exchanges data with the Logix controller using a Class 1 Ethernet IP connection. This application example allows the user to either replace the GEM.io with Rockwell Automation I/O or replace the legacy HMI with FTView. In the second application example, the HDLC router can be used to emulate up to 10 slaved devices on the HDLC network. This will allow the user to replace legacy I/O and drives with newer Rockwell Automation drives without changing any of the GEM80 PLC code. In this example, the HDLC router must be used as a slave on the HDLC network and exchanges data with the Logix controller using a Class 1 Ethernet IP connection. Next, we provide some of the migration options and an example of a phased migration approach using the HDLC router. The HDLC router allows for a phased migration approach, which can be executed over a period of time. This approach reduces risk and downtime because the installation can easily be switched back to the legacy system, and only selected sections can be migrated without the need to replace the entire system. In the original phase migration example, the current legacy system is operating with the GEM80 controller communicating with drives over the StarNet or HDLC network, as well as the existing HMI. In phase 2 of the migration, the HDLC router can be used to connect a Logix controller to the GEM80 PLC. This will allow the user to remove the legacy HMI and replace it with FTView. The HDLC router will in turn allow the Logix controller to read and write data to the GEM80 controller via the StarNet card. In phase 3 of the migration, the legacy drives can be replaced with newer Rockwell Automation drives which connect directly to the Logix controller, which exchange data with the GEM80 controller using the HDLC router. The last phase of this migration example, the legacy GEM80 controllers start to be replaced by the Rockwell Automation Logix controllers. Using the HDLC router, the Logix controller and GEM80 controller can operate and monitor concurrently, and sections of the operation can be transferred from the GEM80 controller to the Logix controller, up to the point where all the logic resides in the Logix controller and the GEM80 PLC can be decommissioned. In the following section, we will provide a basic overview of the configuration required for the HDLC router and how that translates into a working solution. All Aparian modules are configured using the Slate configuration utility, which can be freely downloaded from the Aparian website. In the general configuration, the module requires a name and an IP address for the Ethernet network. The HDLC section of the configuration allows the user to configure the various modes and settings required for the HDLC operation. The data mapping section allows the user to configure which HDLC nodes must be communicated with when operating in the HDLC master mode, or which HDLC nodes must be emulated when operating in HDLC slave mode. Each mapped item represents a node on the HDLC network and requires an input and output size. The input and output mapped area for each device is then mapped to configurable areas in the Logix input and output assemblies, allowing the Logix controller to access the data from the HDLC devices. The HDLC router exchanges data with the Logix controller using an Ethernet IP Class 1 connection. The HDLC router is added to the Logix I/O tree under a Rockwell Automation Ethernet bridge, for example, an EN2T module. The last section will show some of the diagnostics that the HDLC router provides. This information can be used to increase the speed of fault finding to minimize downtime. The HDLC router provides numerous statistics and diagnostics for the HDLC and Ethernet networks. There are also specific details for each HDLC node that is being communicated with or being emulated. All of these statistics and diagnostics can be accessed via the Slate utility or the module web server. The Slate configuration utility also provides an HDLC packet capture functionality, which can be used to analyze the HDLC traffic if there are communication issues on the HDLC network. This concludes the product overview of the Aparian HDLC router. For more information regarding the product, please visit the Aparian website or email us at sales@aparian.com.